All right, let's talk about work in terms of physics. Work is the energy transferred to an object by an applied force over a measured distance. So here's our little stick man. There's a big heavy box. He's going to apply a force to it. He's going to move it up over his head. Bang. So there has been two things that are required. There's a force involved. In this case, it would be the force of gravity that's acting on this box. That's what he has to overcome. And I guess the other thing is distance. I need some distance. This thing's got to move. Whatever we're acting on, it's got to move. Two examples where I'm doing what we would call zero work. Over here, it's above his head. He's carrying it. He's holding it up there. And then he moves. He runs over this way a bit and runs back. Yeah, it's always carrying it at the same height over his head. That is zero work. Sure, he's moved, but in this case, he's moving this way, and the force that he's applying is this way. So we get zero work because they are perpendicular to each other. Another case of zero work is somebody pushing on a wall, and he can push on that wall for as hard as he possibly can from now until the end of time. And it does not matter. The wall does not move. Distance is zero. Zero work. Okay? Now, hopefully you realize that if I have a bigger force, I'm probably going to do more work. So we can say that F is proportional to, W is proportional to F, means if F gets twice as big, the work should get twice as big. If F gets 3 times as big, the work should get 3 times as big. Also, it would be proportional to the distance traveled. Yes? If I move it twice as far, I should do twice as much work. And this gets us, we say that work is measured in joules, the same units that we measured energy in because they are one and the same. Work is energy transferred. Right there, it says it right there. Work is energy transferred. So that shouldn't surprise us that the units for both work and energy are the same. And so I guess I need a formula here. Work is equal to FD, but not just FD, because sometimes things aren't. That's only if it's acting in the exact same direction. Here's a case where I'm pulling a ball on a rope, and the force is acting up this rope, but the distance traveled is this way. Yes? These aren't in the exact same direction, so we've got a bit of a problem. And so what we need here to answer the question is this guy, theta, and it's work equals FD cos theta. And we'll put a box around that, just like that. There's the formula for calculating work. So let's go down here and we'll do a really simple question. John lifts a 5 kilogram box to a height of 2 meters. So I'm getting, oops, let me do that in black. I'm getting that the mass is 5 kilograms. I'm getting that the height is 2 meters. And it's asking me for how much work is done. I get my formula out. Work equals FD cos theta. The angle between these two things, where he's lifting up, the distance is up. The angle between these is 0, so I'll put theta equals 0. They're both pointing in the same direction, so the angle between them has got to be 0. The force here happens to be, if you're lifting something, lifting this box, you're fighting against the force of gravity, so I'll put FGD cos theta, and the force of gravity is equal to mg d cos theta, which is 5. I'm going to use 10 instead of 9.8 so that I can do the math in my head. 2 times the cos of 0, which is 1. So I'm going to get 50 times 2 is 100 times 1 is 100 joules. He's doing 100 joules of work as he lifts that over his head. One last example here. This guy's different. Frictional force. Here's my car. Yes. It's traveling this way. Yes. That's its distance is going to be this way if it's traveling forward. Car's moving that guy. But friction is acting this way, in the opposite direction. And so, what is the angle between these? Between two lines pointing in opposite directions is 180 degrees, yes? 180, yes? So I'm going to plug in. I get my friction is equal to 50 newtons, or force is equal to 50 newtons. Distance is 40 meters, and theta here is 180 degrees. I get my formula out. Work equals FD cos theta. 50 times 40 times the cos of 180 is equal to 2,000, and this thing is -1, so I actually get a negative answer. When the two vectors, their distance and their displacement and force are pointing in the opposite directions, we say that negative work is being done. Negative work is being done. Answer came out negative. So it's just another scenario. So there's positive work, like in the first example. There's negative work, like in the second example, when the two things are acting in opposite directions. And then don't forget, there's zero work, where one of the two values is 0. And that is just a brief little input on force. See ya.